Let's now see how the open-close principle is applied to the visitor and composite pattern. So let's review what open-close principle is. Open-close principle simply means, so given any architecture of your system, so you can always decouple the system into two parts. One is open, the other one is closed. Open part is always open for extension, and the closed part should be always closed for modification. Okay, so now in the case of the visitor pattern, so this is how it should be how it should be designed. The open part should be the extension for the operation. So which means for the visitor here, every time if you just want to support a new operation, you can just add a new class over here. For example, code generator over here. Okay, I'll demonstrate it to you using iFlow Studio. On the other hand, what's really close for this pattern here is the structure that the visitor is visiting through. In this case, if let's say you are trying to add a new structure components over here, let's say subtraction. In this case, you're adding a new subclass under expression over here. However, you can imagine that you also need to add a new visit subtraction over here under visitor. So what's the consequence of that? That means for every operation that you're already supporting, you have to modify in multiple places to support that visit subtraction feature. So that violates the single choice principle. Okay, this is why we say for the visitor pattern, it is really crucial for you to notice that if you find that it's way too often for you to touch this closed part over here, which is the structure that you're trying to visit over. If you way too often you have to modify this part here, then visit pattern is not the way to go. On the other hand, if you find that you always just want to support a new operation on the very stable language structure over here, then in that case, visitor pattern is the way to go. Okay, let me illustrate that to you very quickly on iFlow Studio. Let's go to iFlow Studio over here, and that's our project. I want to show you also one more thing first. And you can, even though we have asked you to really generate your bound diagram, the bound architecture diagram for your design, you can always try to get an idea how the classes in your design are related to each other using iFlow Studio. Okay, let's now, first of all, I want you to see under over here, you have some panel option here called diagram. Click on diagram here. You can also try to pin it over here. Okay, so it's not really auto hidden. So now over here, you can drag and drop as many clusters as you like, depending on what classes you want to see the relationship over here. So for example, here you can put tests. Rather than tests, I can put, for example, structure. Okay, so now I got both structure over here and also operation. So if in case you don't see operation here, you can always just right click, for example, right click on the operation and right click again on pick. Okay, and then you can put it here. Okay, then you'll be there. Let me just put one more. What about the test? Okay, I can also put the test over here, right click, pick, right click, and then put it here. Okay, so now we got the three cluster over here. You can just organize your diagram a little bit using your mouse. But let's say I just want to show you something quickly. Okay, you can see that you got different options over here. You got client supplier, you got also inheritance. You can choose to either show them or not to show them. Okay, so now in this case, you can see that we got client supplier, we got inheritance all over, but you can also choose to hide them as well. Okay, you can play with the diagram and see some draft of your architecture design, and then you can convert that into a much more professional looking diagram in io.draw. Okay, or whatever diagram tool you're using. Okay, that's just an aside. Now, let's hide it, and now let's illustrate the open-close principle for the visitor pattern. Let's see how we can violate the single choice principle. If, remember for the visitor pattern, the open part is the operations, and the closed part is the structure. Now under structure over here, if we are trying to touch this closed part, then we will violate the single choice principle. Let's see why. Let's say I'm trying to add a new class over here called subtraction. Over here, and subtraction is, and it's going to inherit the expression. And of course, we gotta support the accept feature, right? and then we can say accept over here, and then we can say v of type visitor. Okay, over here, let's just say that. Oh, not run. Let's compile. Okay, let's stop that. I don't want to run. Okay, let's just compile. Okay, everything compile, but now you can see what's really important is because you actually say accept. So now, how do you increment this accept over here? What you should do is you should say v dot visit subtraction. Okay, v dot visit subtraction. But of course, we haven't defined that yet. I will do that in a moment. Visit subtraction, and then over here, also you can see current, just similar to how you define the accept in addition and also in constant. So now the consequence of this is we have to go to operations over here and go to visitor. Now we're going to add a new visit feature. Visit over here, and then I'll say subtraction. Over here, I can say a subtraction. And then deferred n. Let's see after this, let's see what's going to be the case. Okay. Now, if I say compile, you can see that visit subtraction is not defined in evaluator. For this, our small example over here, we only introduced the evaluator. But imagine this, if we also got pretty printer, we also got type checker. In this case, every one of them has to implement this new visit subtraction feature in 3 different places. So that violates the single choice principle. Okay, now, so hopefully you see the point. So now what I will do is I'm going to just define this very quickly just to make things compile. Okay, and then I'll just go to the evaluator over here. Okay, and then I can simply just copy and paste for visit addition. I can say visit subtraction. Okay, also here you got subtraction over here. Okay, pretty much the same as you can say minus, right? You can write the test cases for that if you like. Okay, we got left and right. Okay, so now what I will do is let's just go to addition over here so we can actually just copy and paste. Okay, let me just do this. Okay, let's go back to subtraction over here, and now I just need to change a few things. One thing, all I gotta change is visit subtraction. Of course, you can make your code a little better rather than duplication. Okay, I'll leave that to you. Okay, everything compile. Okay, so what we just illustrated was if you try to add a new class under expression, so that means for every descendant classes for the visitor, you have to define the visit, for example, visit a subtraction for every one of them. So that violates the single choice principle because you're touching the closed part. So now what about touching the open part? The open part will obey. Touching the open part will still obey the single choice principle. Why? Let's see. Now let's say I want to add a new operation over here. Let's say pretty printer. Okay, we haven't done that yet. Let's do that very quickly. So what I will do is I will simply have to introduce a new class over here. I can say pretty print. Pretty printer. Okay, so now pretty printer here should be it should inherit over here visitor. Okay, as soon as it say compile, it's going to complain that over here because we inherit some visitor, so we haven't defined these 3 features yet. Okay, but now you can notice that I can simply do them over here. I'll show you. So if I go back to pretty printer over here, there's only a single place I'm making this change, which is this new class over here, which means I introduce a new descendant class under visitor, and that's the only class I have to touch. Okay, that still obeys the single choice principle. So I can just paste that over here, and then I can say do n, okay, do n, and also do n. Okay, as if I try to compile, it compiles. Okay, I'll leave the implementation for pretty printer to you. Okay, that'll be an exercise for you. Okay, so now hopefully you will see that the open close principle If you're trying to touch the close part, in this case, you will violate the single choice principle. If you try to touch the open part, you will still obey the single choice principle. Okay, that's really important to notice.